Here from the logic you can understand. So this is, you can see a 7 segment display which is generally used in traffic lights. If you have seen that it changes the number, and how does that change a number? Because in a digital circuit, how we can display this decimal number? So that is the work of a decoder actually. So a decoder is a device where there are n number of inputs are there and there are m number of outputs. And what is the m value and n value? Basically, if n number of inputs are there, it can have maximum of 2 to the power n, that is what written here. Okay, maximum of 2 to the power n, but it can be less than 2 to the power n also. So it's not mandatory that every time it will be 2 to the power n, so it can be less than 2 to the power n. Now what a decoder can do? So basically decoder is implemented when I have to convert n input lines to 2 to the power n or less number of outputs. When I have this conversion problem, we use a decoder there. So why it is called as a decoder? Because from a small number of inputs, I am increasing the number of inputs. Basically, I am decoding a message there. So a message is coded with a small amount of information is there, but you are decoding that to a higher amount of information. That's why it is called as a decoder. Now one of the application is here you can see a BCD to 7 segment display. So this is the most of the highest use case of decoders. A 7 segment display is there. So this is what you see is a 7 segment display. What other things it can do? We can implement some Boolean expressions. We can implement Boolean expressions as well. With the help of decoder, what else we can do? We can implement adder circuits, adder subtractors. So everything we can implement with a decoder. Now let us start with a basic decoder and how does it work, we'll see. So we'll start from a decoder, a 2 cross 4 decoder. Why it is called 2 cross 4 decoder? Here you can see there are two inputs, A and B is taken, and total number of output is D0, D1, D2 and D3, that is 4. So 2 inputs, 4 outputs, and it is called as a 2 cross 4 decoder. If you see the relation of n and 2 to the power n here is equals to 2, and the number of output, that is m, is equals to 2 to the power 2, that is equals to 4. Okay, so this is a basic architecture of a decoder. Next part is how it is designed, how does it work. So that let's see that. So here you can see this part is the input A and B, and here D0 to D3 are my output. Okay, how to work? So if the input is equals to 0 0, if there are two variables, obviously I can have 4 variations only. So 0 0, then it will indicate that the output D0 is equals to 1 and other outputs will be equals to 0. That means if 0 0 is the input, and let's say a D0, D1, D2, D3 all are LEDs connected, or any lamp is connected there, then D0 lamp will glow, all other lamps will remain in the off state. That is what it means if the input is 0 0. If the input becomes 0 1, then it will indicate D1. That means if the input is 0 1, then what will happen? D0 will be off, the LED here connected will be off, D1 will be on, and all other LEDs will be 0. So that is how a message will be decoded. Next is if the input is 1 0, then D2 will be activated similarly, and if the input is 1 1, then your D3 will be activated. Fine. Now how to draw the circuit with the block diagram or this symbol we cannot implement in a circuit. So how to draw the circuit, right? So to draw the circuit, what we need? We need the Boolean expression for each and every output. So D0 is a single output, D1 is a single output. So we need to write what is the Boolean expression of those elements. Fine. So first we'll find that what is the Boolean expression for D0. How to find? So generally this is written in the SOP format. Wherever the value of the function is equals to 1, we write the corresponding value in the SOP format. Now if you look into this column D0 only, then here is the value is equals to 1. This is the only place where it is 1, all other places it is 0. So the corresponding values in the SOP format we have to write. So it becomes A dash B dash. Okay. Next is D1. So what is D1? D1 you can see it is 1 here. Fine. And the corresponding variables are A dash B, I will write here. Similarly, D2 is what? So D2 you can see it is here. So the corresponding value variables will be A, B dash, and similarly D3 will be equals to AB. Fine. So these are what? These are the Boolean expression required to construct my decoder. Now how to draw the circuit? So basically drawing the circuit is very easy here. So what I am doing, I'll take one variable as A. So this is one single line for A input, and as we need A dash also, so I am taking a NOT gate and I am drawing one parallel mode line. Next input we have is B. So for B the input line I'll draw like this, and because we need B dash also, I'll put a